Welcome to Lucid Mind Chemistry channel. In this video, I have compiled questions related to balancing of redox equations in neutral and acidic medium using changes in oxidation numbers. For similar topics and question timestamps, read video description. Question 8. In this question, you should use changes in oxidation numbers to balance a chemical equation. Acidified potassium dichromate solution can oxidize a solution of V+2 ions. The equation for this reaction is shown. What is the ratio A-B in the correctly balanced equation? Now let's first find out the oxidation state of chromium in the reactant side and the product side. So on the reactant side, we have Cr2O7-2. There are 2 chromium atoms, plus there are 7 oxygen atoms. Each oxygen has a charge of -2, and the overall charge is also -2. 2 chromium minus 14 is equal to, or you can say 2 chromium is equal to plus 12, and each chromium will be plus 6. So the charge on one chromium atom is plus 6 on the reactant side, and the charge is plus 3 on the product side. Now going from plus 6 to plus 3, the oxidation state is reduced, so it means it is reduction. Vanadium is in plus 2 oxidation state on the reactant side, and in the product side we can find the oxidation state V plus, there are 3 oxygen atoms, so -6 for oxygen, and overall charge is -1. So vanadium is plus 6 minus 1, so it will be plus 5. So it goes from plus 2 to plus 5, that is oxidation. Now there are several steps to balance the redox reactions. First one is to write the half equations. One of the half equation is of reduction and second one is of oxidation. So let's write the reduction first. Cr2O7-2, it goes into Cr plus 3. Now the oxidation equation is V+2 and it converts into VO3-. Now the second step is to balance the atoms other than oxygen atom and hydrogen atom. There are 2 chromium on the reactant side, so just balancing chromium, and vanadium is also balanced. Now balance the number of oxygen atoms by adding water molecules on the opposite side. With Cr2O7 there are 7 oxygen atoms, so we have to add 7 water molecules on the product side in order to balance the oxygen atoms. Similarly, for the oxidation equation, we can add 3 water molecules to the reactant side in order to balance the number of oxygens. Now we can balance the number of hydrogen atoms by adding H+ ions on the opposite side of the equation. For the first equation, reduction equation, we have 14 hydrogen atoms on the product side, so we can add 14 H+ ions to the reactant side. Similarly, we can add 6 H+ ions in order to balance the number of hydrogen atoms in this equation. Now another step is to balance the charges by adding electrons on either side of the equation. We have plus 14 charge minus 2 charge, so the overall charge is plus 12 on the reactant side. We have plus 6 charge on the product side. So we can reduce the charge by adding electrons. So we can add 6 electrons to the reactant side, so it will become plus 6. Similarly, calculating the charges in the second equation, we have plus 2 charge and -1 and plus 6. So the overall charge is plus 5 on the product side and plus 2 on the reactant side. It means we can add 3 electrons to the product side in order to balance the charges. Now next step is to balance the number of electrons. In both equations we have 6 electrons in the first equation and 3 electrons in the second equation. So the second equation must be multiplied by 2 in order to equalize the number of electrons lost and the number of electrons gained. Now rewriting the chemical equations, 14H plus Cr2O7 minus 2 plus 6 electrons gives 2 Cr plus 3 plus 7 water molecules, and the second equation is 6H2O plus 2 V plus 2 ions, 2 VO3 minus ions, and 12 H plus ions. Combining the two equations, we can get 14H plus Cr2O7 minus 2 plus 6 water molecules plus 2 V plus 2, and it gives 2 Cr plus 3, 2 VO3 minus 7 water molecules and 12 protons. I haven't written the number of electrons because the number of electrons lost and gained will cancel out each other. Now in the question they have asked about the ratio A ratio B, which is between Cr2O7 and V plus 2. So we can find this Cr2O7 and V plus 2, the ratio comes to be 1:2, and therefore the answer is B. Question 5. In this question, you should use changes in oxidation numbers to balance a chemical equation. The following reaction occurs when manganese dioxide is warmed with dilute sulfuric acid. What is the ratio of C ratio D in the correctly balanced equation? So we have to find the ratio between the manganese ions and manganate ion. Let's first find out the oxidation state of manganese in both manganese dioxide and manganate ion. As we know that the overall charge in MnO2 is 0. So Mn, there are 2 oxygen atoms. The charge on the oxygen atom is -2. And the overall charge is 0. So we have Mn minus 4 is equal to 0, or Mn is equal to plus 4. So the oxidation state of manganese in MnO2 is plus 4. In MnO4 minus, we have 1 manganese atom, 4 oxygen atoms, so 4 into -2, and the overall charge is -1. So the oxidation state of Mn is plus 7. Now in this equation we can see that manganese is being oxidized to plus 7 and also being reduced to plus 2. So we can write both chemical equations, first for oxidation and second for reduction. So in oxidation, MnO2 actually converts into MnO4 minus. In reduction, we can see that MnO2 is being reduced to Mn plus 2. First step is to balance the atoms other than oxygen and hydrogen. So we have Mn and Mn balanced in this equation. We also have manganese balanced in this one. The second step is to balance the number of oxygen atoms by adding water molecules on the side having less number of oxygen atoms. So let's add H2O to this side. Now we have to add 2 water molecules in order to balance the 4 number of oxygen atoms. In this equation we can balance by adding 2 number of water molecules so that the number of oxygen is balanced on both sides. As this equation is in acidic medium, so we have to balance the number of hydrogen atoms by providing hydrogen ions on the opposite side. In the reactant side we have 4 number of hydrogen atoms, so we can balance that by providing 4 protons. For second equation we also have 4 number of hydrogen atoms, so we can balance that by providing 4 H plus ions. Now in the next step we have to balance the charges. We have -1 for MnO4, we have 4 plus or +4 for H plus ions. So the overall charge for this equation is +3. So we can add the number of electrons in order to balance the charges. On the reactant side we have 0 charge because both the water and MnO2 is neutral. So we can add 3 electrons so that this part also becomes neutral. In the second equation we have +4 charge and 0 charge on MnO2, +2 charge on Mn and 0 charge on water. So we can add 2 number of electrons to the reactant side in order to balance the charges on both the sides of the equation. Now we can see that 3 electrons are lost in one equation and 2 electrons are gained in the second equation. As in balancing, the number of electrons lost should be equal to the number of electrons gained, so we can multiply this equation by 2 and this equation by 3. Now after multiplication we will have 4 molecules of water, 2 MnO2, 2 MnO4 minus 8 protons and 6 electrons. For the second equation we will have 12 H plus, 3 MnO2, 6 electrons, 3 Mn plus 2, 6 water molecules. As now both the equations are balanced, so we can see that the ratio between Mn plus 2 and MnO4 minus is 3:2. So the answer should be D. Question number 10. Acidified potassium manganate 7 reacts with iron 2 ethane diOH. The reaction taking place are shown. How many moles of iron 2 ethane diOH reacts with 1 mole of potassium manganate? They have given us potassium manganate and iron 2 ethane diOH. Let's find the oxidation states. Iron is +2 as they have given in this equation, and overall the molecule is neutral, so therefore the charge on ethane diOH will be -2. The reaction of ethane diOH is given. It converts into carbon dioxide and releases 2 electrons. The reaction of iron plus 2 is also given. It converts into iron plus 3 and loses 1 electron. So both these reactions are oxidation, as electrons is being lost. In this reaction of manganate iron we can see that 5 electrons are being gained, so therefore this is reduction equation. So in order to balance this chemical equation, the number of electrons lost must be equal to the number of electrons gained. In reduction 5 electrons are involved, while in oxidation 1 plus 2, so total 3 electrons are involved. So in order to balance 3 and 5, we can multiply the first equation with 3, so it becomes 15 electrons. And we can also multiply these two equations with 5, so it also becomes 15 electrons. After multiplying we can write 3 MnO4 negative reacts with 24 H plus and 15 electrons to give product. For the second equation, we can write 5 Fe plus 2 reacts to give product. C2O4 is also multiplied by 5, so we can write 5 C2O4 negative 2 gives product. I'm not writing the product because in the question they have given iron 2 and KMnO4, so we just have to find out the number of moles of MnO4 and iron plus 2. Upon adding all these three equations, we can get 3 moles of MnO4 negative reacts with 5 moles of iron plus 2, 5 moles of C2O4 negative plus 24 moles of H plus 15 electrons and gives product. So the only concern is with MnO4 negative and iron plus 2. So we can write MnO4 negative, iron plus 2. The molar ratio according to the balanced equation is 3 to 5. In the question they have asked about 1 mole of potassium manganate, so if it is 1 then this will be X. Cross multiplying, we have 3X is equal to 5, or X is equal to 5 divided by 3, which is equal to 1.67 moles. So therefore answer is B. Question number 9. In the chemical equation W, X, Y and Z are all whole numbers. We have this equation. When the equation is balanced, what are W, X and Y? We can see that this equation is a redox reaction and the medium is acid. Let's balance this redox equation. We will follow these steps. First is to write half equations. For this step, we have to find out the oxidation states. Let's find out the oxidation state of Cl, Mn in the equation. So we have ClO3 negative, MnO4 negative, ClO4 negative, and MnO2 neutral. So we have 1 chlorine atom, 3 oxygen atoms, and overall charge is -1. We have 1 Mn, 4 oxygen atoms, and overall charge is -1. For ClO4, we have 1 chlorine atom, 4 oxygen atoms, and overall charge is -1. Similarly, for MnO2, we have 1 Mn, 2 oxygen atoms, and overall charge is 0. For oxygen atoms, the oxidation state is -2. So for 3 oxygen, it will be -6. So chlorine will become +5. Similarly, in this compound, we have 4 oxygen atoms. So the charge will become -8, or Mn will become +7. In ClO4, we have 4 oxygen atoms. So again, it will become +7. In MnO2, we have 2 oxygen atoms. So Mn will become +4. So the oxidation state is +5, +7, +7, +4. Now we can write the half equations. As we can see that Cl is moving from +5 to +7. So oxidation has taken place, while Mn has moved from +7 to +4. So reduction has taken place. So the oxidation equation will be like this: ClO3 negative. It converts into ClO4 negative. Second half equation is MnO4 negative. It converts to MnO2. Now second point is to balance oxygen. By adding H2O on the opposite side. Now in the first equation we have 3 oxygen atoms on the reactant side and 4 oxygen atoms on the product side. So we can add water molecule on the reactant side to balance oxygen. Similarly, in reactant we have 4 oxygen atoms and on product we have 2. So we can add 2 H2O to balance oxygen atoms. Third point is to balance hydrogens. By adding H plus on opposite side. In first equation we have 2 hydrogen atoms on the reactant side, so we can add 2 H plus to the product. In second equation we have 4 hydrogen atoms on the product side, so we can add 4 H plus to the reactant side. Next point is to balance charges by adding electrons. Let's find out the charges. On the reactant side we have -1 charge. On the product side we have -1 and +2 charges for 2 H plus. So the overall charge is +1. Now in order to balance -1 and +1, we have to add 2 electrons on this side. Now the charges are balanced. For second equation we have -1 on MnO4 +4 on H plus, so the overall charge is +3. On product side we have 0 charges, so it is neutral. So in order to make the reactants neutral we must add 3 electrons. So we can write 3 electrons with the reactants. Fifth point is to equalize electrons by multiplication. As in the first equation 2 electrons are lost, but in the second equation 3 electrons are gained. Now the number of electrons lost must be equal to the number of electrons gained, so we can multiply the first equation by 3 in order to make it 6 electrons, and we can also multiply the second equation by 2 in order to make it 6 electrons. Now the first equation will become like this. We have 3H2O, 3ClO3, negative, 3ClO4, negative, 6H plus and 6 electrons. The second equation will become 6 electrons, 2 MnO4, negative, 8 H positive, 2 MnO2, 4 water molecules. The last step is to add both equations. Now we can see that number of electrons lost is equal to number of electrons gained, so we can cancel them out. Similarly, we have 6 H positive formed and 8 H positive gained, so it will cancel to become 2 H positive. Now we can write both equations. 3H2O, 3ClO3 negative, 2 MnO4 negative, 2 H positive. It forms 3ClO4 negative, 2 MnO2 and 4 H2O. ClO3 is given as W, so W is equal to 3. MnO2 negative is given as X, so X is equal to 2. H plus is given as Y, so Y is also equal to 2. The answer is therefore D. Question 15. Chlorate ions ClO3 negative are produced in the redox reaction between chlorine and hot aqueous sodium hydroxide. Oxidation numbers can be used to help balance the equation for this reaction. What are the values of V, X and Y? So V is Cl2, X is Cl negative and Y is ClO3 negative in the balanced equation. Let's first find out the oxidation state. Cl2 is in the molecular form, so therefore oxidation state is 0. In Cl it is given as -1. In ClO3 it will be like this. We have 1 Cl and 3 oxygen atoms, and overall charge is -1. So the oxidation state of 1 oxygen is -2, so for 3 it will be -6, and Cl will become +5. So it is +5 in ClO3. We have to find values of V Cl2, X Cl negative, and Y ClO3 negative. Let's write the oxidation reduction equations. So in first reaction, chlorine gas converts into chloride ion upon reduction. We can balance number of atoms as there is only one atom on product side, so we can write 1/2 on the reactant side, so it would be balanced. As half chlorine will gain 1 electron in order to form chloride ion. Therefore, I wrote 1 electron on the reactant side. Second equation is the oxidation from Cl2 to ClO3 negative, so we can write Cl2, ClO3 negative. Again, in order to balance the number of chlorine atoms, we have 1 chlorine atom in the product, so I can write 1/2 with the reactants. As the oxidation state of Cl in the product is +5, so 0 into +5 means 5 electrons are lost by chlorine, so I can write +5 electrons. The first reaction is reduction and second reaction is oxidation. As we know that in balanced equation, the number of electrons lost must be equal to the number of electrons gained. So we can balance these number of electrons by multiplying this equation with 5. So rewriting the first reduction equation, now I have Cl2, Cl negative. 5 is multiplied by 1/2, so it will become 5/2 for chlorine. The number of electrons will become 5. The number of chloride ions will also become 5. Now combining both of these equations together, I can write 1/2 plus 5/2 will become 6/2 Cl2. Electrons lost and gained will be cancelled out. The product formed will be Cl negative and ClO3 negative, and with Cl negative there will be 5 moles. Instead of 6/2 I can write 3. So V will become 3. X is equal to 5 moles and Y will be equal to 1 mole. So the correct option for V is 3, for X is 5 and Y is 1. So therefore answer is C. Thanks for watching. If this was useful, please do like, subscribe and share.